and scalability as well. So when the panel got together and we had our kind of initial calls to discuss, we learned that there was a lot of commonality between our panelists who had not met before, but found like, man, these guys, they're gonna be best friends, I have a feeling. They're all kind of very aligned with what they're doing and their vision. And you know, I love that we were able to make the connection early. And so I wanna go down the line. We have Craig Beaver from Beaverton. He's the Administrator of Transportation. Beaverton's out in Oregon. And Craig has been doing some amazing things. He takes the data that he's learning in the real world fleet and he's sharing it on his public website. So this is a really great informational tool, and we're gonna be able to share some of those stats throughout the presentation today. And then also have Alex Cook. Alex Cook, he was also a previous Innovator of the Year award winner. And Alex is the Chief Engineer at First Student. So Alex is an amazing individual. He has got tons of experience in the area of electrification and energy and handles everything in the First Student environment. And complete first. So yeah, so that's a big one to tackle, Alex. So a lot happening. And then we have Kian Fields. So Kian is the manager for school bus fleet electrification for Boston Public Schools. So we're so glad you're here, Kian. Thank you so much for coming and being a part of the conversation. So Alex, why don't I start with you? You got the biggest fleet out there, and you have, from what I understand, over 500 electric school buses deployed today. Is that correct?
Yeah, it's actually, Tony, if you took a look at all of North America, we've got just south of 500 in total. I think we have the largest North American school bus deployment going on right now in Montreal, and there's a total of 300 there. And if you look at moving to the future, I think we're somewhere around 34 in-flight projects with another 80 in the queue, tallying up to somewhere in excess of 2,000 vehicles.
Excellent. How about yourself, Craig? Give a little background on Beaverton.
Beaverton is a suburb of Portland, Oregon. We're on the west side of Portland, 40,000 kids in our district. We're currently operating 25 electric buses right now, and we'll have 30 in operation here in the next month or two. But we're scaling up. We'll have 90 electric buses by this time next year through the benefit of the EPA Clean School Bus Grant. We were fortunate enough to receive $20 million from them. So we're really looking forward to it, and in the process of scaling up infrastructure with that as well.
Excellent. And Kian, you want to give us a little background on Boston Public Schools?
For sure, yeah. So Boston Public Schools has 750 school buses. About 20 of those are electric right now. We've been running those for the past 18 months. We're currently putting in infrastructure for another 20 this summer. We're really focused on simplifying the infrastructure install, doing it faster, simpler, cheaper. But so last week I was literally in a trench. But yeah, we're hoping to add another 95 buses in the next 2 years, 95 electric school buses. So again, thanks to the federal government.
Excellent, thank you for that. So Alex, let's talk a little more, because obviously you've scaled, right? And you're continuing to scale. Can you talk a little bit about what you've learned through that process? Obviously, you're in different topographic areas, different environmental areas in terms of heat and cold, mountainous, flatland, coastal, inland, operating in suburban, urban, you know, metro. So what can you give the audience that they can kind of take away, and just from your experience, can you give us a little high level kind of, as someone's looking to deploy or they're in the early stages of deployment, some of the things that you learned along the way?
Yeah, it's interesting, Tony. Craig and I were just having this conversation this morning. You know, when you talk about success, right, and we're all transitioning to an EV space, we're all on the same journey of destination zero. And what we can do together as an industry to make sure that we learn from best practices for those that may be doing it at a larger scale than others right now, I think in the end is going to greatly help and accelerate that destination to zero curve. So, you know, there's a couple of things there, you know, and you said a lot there in your opening statement. A couple of quick things there back to ensuring the success. Number one is truly, really understanding your duty cycle. And so if you look at us, for example, we've got a model that we put together that takes into account a whole litany of variables that looks at the duty cycle, sizes up a battery for a charger, for a dwell time. We as engineers, and I have a little bit of a biased opinion here, I always take the ultra uber conservative approach, right? So we have to make sure that, let's say 90% of the time, and I know there's a lot of numbers, and Craig, we're going to get into your numbers on a kilowatt per mile, and if you look at the duty cycle and how you run the vehicle, and maybe a majority of the time you're down in that lower kilowatt per hour consumption, but there's a certain amount of time you're in the higher kilowatt per hour consumption based on environment or other impacts, you have to make sure you account for the worst case scenario. You still have to operate the bus to take the children to school, even on the higher end of consumption and the lower range. So that's takeaway number one. Takeaway number two is the other thing to take into account, right, and there's this thing called SOH, state of health, right? So we know, and there's a lot of data globally, maybe not so much right now in our marketplace, on different chemistries of different batteries, and based on how you hold and move the energy out of those batteries, what's the resultant impact to state of health? So as you start to charge, discharge, you know, V to G, so forth and so on, you've got to make sure that whatever your own internal company's depreciation and what you think the end of life of that bus is going to be, make sure that you account for that on that state of health, because you not only have to run the bus on day one when you got it brand new, but let's say, you know, you're anticipating that bus is going to last, you know, 12, 13, 14 years. It still has to run it out there on the back end. So from a successful standpoint, understanding those nuances, that you accommodate for those on the front end, will take you a lot farther down the successful path of being able to deploy and scale this technology.
And I'll pose the same question to you, Kian.
Yeah, and I think we've actually recently explored this with some fleet planning, actually some of whom are in the room right now. They pegged that state of health degradation at 80% of the original. And so, yeah, I guess I just want to try and push the answer or the solution there of prepping and like, if we're worried about the worst case scenario for battery health, I think it's about 80%. So yeah, we'd just love to share that with the other school districts in the room. But yeah, we're definitely keeping that in mind too. I think we also have the worst case scenario is dead of winter and a field trip plus a bunch of athletics.
You tell me Boston's cold? Is it?
Yeah.
Just,
Yeah.
Just a bit?
And I love talking to first student about Montreal as well, because that's a favorite topic and area we need to push on everybody. But yeah, I think the state of health is a really strong point, and just looking for that worst case scenario, because I think planning for that is important. And I guess maybe as the school district in the room, I'll say still go for it, because you can take, you know, that final 10%, those final buses, they could be your last buses in your fleet to transition, and the bus with the lower duty cycle could be electric in the near term.
Sure. And then Craig, so with you, in terms of fleet size, so you have the smallest fleet of everyone, but also my first reaction was Beaverton, Oregon. That sounds cold, but you said, no, it's a little more moderate temperatures.
I have to admit, we have 320 buses and 260 plus drivers. It's the first time I've ever been called the smallest district. So, but yeah, you know, I will say there's good news. Pacific Northwest, yeah, we get snow, but it's really limited. The cold weather is limited to maybe 2 weeks a year, that kind of thing, maybe 5 to 8 snow days a year. So it's not all doom and gloom west of the Rockies. We in fact are really diving into level 2 chargers so that we can really minimize, if you will, the effect of the batteries. And our dwell times, because of our routes, are 11 to 13, 14 hours. So we have that time overnight that we can use the level 2s on the ACs, which is considerably cheaper. I mean, I have level 3 DCs, and whenever I use them, my electric bill shows it immediately. So, so there is good news for those in warmer states. I won't speak to California, but I'm thinking, the Arizonas and the New Mexicos and places like that, Nevadas. I think we're fortunate in that we're not going to get that real cold weather. We're not going to see as much of degradation over the battery that some of our friends in the colder states are going to get. However, I listen to everything they say. So there is good news out there, and we're going heavily with level 2. Again, that brings up the whole V to G, which I know Alex is heavily involved in, and we're going to talk about a little bit later. But that's just it's just a direction that you need to choose to go. So, but yeah, it's positive news for those of us in warmer climates.
Yeah, I think in our conversation, since we're just kind of on the weather combo real quick, is we talked a little bit about heat bleeding within the cabins and that affecting the amount of energy that's being consumed and your range. You guys want to talk about that, Kean, a little bit? I know this is something near and dear to your heart, as you discussed, so you want to share a little bit. How do you address that challenge?
Yeah, absolutely. I think thermal efficiency, like temperature efficiency, is even more important for an electric vehicle than an internal combustion. So it's more important here, as we say. But I think there's both a workforce component and a technology component to solving this or to just working through it. I want to be clear, we can solve this. Boston is running buses throughout the dead of winter. The range drops down, but we planned for that and we consider it. But so workforce and technology are the two ways I see addressing that. Workforce, we do a bit of a training refresher every October, November, and just really push the importance of keeping the windows closed, using the regen brakes, which will behave just a little bit differently when it's really cold. And then on the technology side, I'll name that Boston uses all Bluebird school buses. And over the past year, we met weekly, actually, with their engineering team and Cummins to really push on preheating the cabin while the bus is plugged in, using our electric cabin heater, so there's no diesel or propane, or there's zero emissions, essentially. But so I was really proud we got to actually launch that and start operating that this past summer, which has been a huge help to just have the cabin fully warm and at 100% state of charge when the bus leaves the bus yard, just to make sure we can get every ounce out of that.
So Alex, are you looking at the same when you're in an area like Quebec that could be very cold?
Well, actually, Tony, it's on both sides. When we're talking about thermally soaking a passenger compartment, right, and that's solely in an effort to extend the range in cold climatic conditions, right, because if you don't thermally soak the passenger compartment, then you're running the resistance heaters in the bus to try and bring ambient temperature up, versus if you can thermally soak all that mass ahead of time, that duty cycle on that resistance heat circuit is much lower, okay? However, if you look at the amount of consumption that it takes away from the charger to do that, number one. Number two, if you look at the efficiency loss through the charger, and they're across the board depending on what the spec sheet for a given charger manufacturer is. Three, there's an efficiency loss through the bus itself. You have to be mindful of exactly, based on environmental condition, what is the energy going in that battery, right? Because we've seen failure after failure where the charger was sized too small to accommodate for the additional parasitic loss, including thermally soaking the passenger compartment, and ultimately they run out of dwell time, and so then they can't run the route the full distance. That's on one side, and I know we spent a lot about cold climatic conditions. That happens on the other side as well when we're in hot ambient conditions. Whether or not I've got a vehicle setting down, out here in Las Vegas, for example. If you've got 100, 110 degree ambient temperature, then you shoot the blacktop and maybe it's 140, 145. And if you're charging, and depending on the rate at which you're charging, the battery thermal management system in the vehicle has to cool the batteries to take the charge. So now guess what? All the cooling fans in the front of the bus are screaming wide open. That as well is detracting from what your charger output is. So the gist of the story is that depending on where your environmental actual location is and what that looks like, always be mindful in that for the dwell time, the range that you need, and how much are you going to consume holistically off of that charger. Does that make sense?
Yeah, absolutely. Craig, you want to comment on that?
Yeah, and one thing that this winter taught us, I take into account, my advice is take into account battery size. We have a handful of our buses that are 155 kilowatt hour batteries, and with the winter, even though we did pre-soak and things like that, the drivers continue to use the heater during their route, 35 or 40 mile route in the morning, and we just didn't have enough using level 2s. We just didn't have enough, enough energy left or enough state of charge left to comfortably do the PM route. So that's one thing we learned. So our purchasing, changed. I think the lowest purchasing we went with was 196 kW battery, but the vast majority of what we're buying are 210 and above kW batteries to help offset that and to still be able to use level 2 charging. So that might be something for folks that are in a more milder climate to think of. That's one of the lessons learned for us.
Yeah, I can quickly just cite our numbers just to echo and agree with what was just said, but our Boston put in 30 kilowatt DC fast chargers, and the heaters, the electric heaters, were pulling about 20 kilowatts, and so that left only 10 kilowatts going into the battery. And so actually what we're facing overnight, that's fine, and first thing in the morning, that's fine. But midday, we couldn't, 10 kilowatts is not enough. And so my first round that I put in last year were 30 kilowatts. The ones going in this summer right now are 60 kilowatt DC fast chargers, so we're hoping to keep pushing it up there.
Yeah, and that's a good transition. I think, looking at infrastructure, because we're talking about fleet efficiency based on certain situations, but I know you talked a lot about lessons learned. There were definitely issues that you learned. There's a steep learning curve, and you've come to a realization. You want to talk a little bit about the infrastructure build out, how many yards you have, what are the ideal conditions, above ground line sets versus underground, because there's a big cost. Looking at microgrids versus just pulling utility in. Give a little background on kind of your journey there.
Yeah, absolutely. I think, so Boston we've got a long way to go, and so we're considering sort of this broad portfolio of approaches forward. And I'll say actually our first round of infrastructure went in last summer, 2023. Went in 8 months. We sort of had a very quick declaration that we were going to go 100% electric, and we were really, really working at that. And part of going so fast, trenching, I think we had heard that trenching is one area that just high risk, you bump into something, it can throw off the project. And also in the winter, you can't really trench. In Boston, it's hard to dig when the ground is frozen. Really. Other big problem is just we have to fit all our construction into the summer, which is another thing I'm trying to just, part of why I want to solve this construction piece is to give ourselves more options there. But so that first round, we went above ground. I'll share it was a little bit more expensive, but it was fast. And granted, this was 2023, 2022 into 2023. I think we've heard the above ground costs have been coming down, so we're really excited to kind of go back to that, especially for the speed. I'll say, and that's skipping a summer, looking ahead. Right now, I'm trenching. We're putting in a big transformer, and the utility was trenching anyway, so we figured we would try out the trenching approach. It's actually going okay so far. We haven't bumped into anything yet, and it actually all happened. It's mostly done, actually. Yeah, knock on wood, but it's mostly done. But I would probably explore above ground next time. The ability to move it, there's so many, and the prices, we've been seeing things come down, so yeah.
How about you, Craig? As you scale your 20 and you add more, what does that look like for you?
Well, we were fortunate. We got into it with help with Portland General Electric, PGE, and Make Ready programs, and so we went underground. The trenching's underground, we finished one. That was great. It was no cost to us. Wound up putting 31 chargers in. And so, it worked out well. We were so far in front of the curve that really didn't run into supply problems. We're in the process of putting in another 36 level 2s. One of the things that's recently come to us, though, is the above-ground model, using whether it's containers like First Student's Fast Charge or other companies where they're bringing in skids. That's really intriguing to us. We don't have to worry about the hard ground and things like that, but the ability to expand and move and relay out the yard is very important. So we're in the middle right now of really evaluating that. And in fact, next week we have a meeting to come to that. You know, with the utilities, at one point it was 60 to 70 weeks for transformer and switchgear. I know that's come down to probably the 40 or 50 week, but what we're finding with some of the above ground stuff is we're looking potentially in the 15 or 20 weeks, which is tremendous. So right now, that's a really big thing on our target. So I hope, you know, hopefully it's going to go that way, because to us, you know, we're going to have 90 buses at this time next year, and the chargers have to be there. We have to do something. So I'm hoping that that's the way to go for us.
Yeah, well, I think you just teed Alex up to talk about the technology that you just mentioned. I know on our call, Alex, you talked about why First Student developed this project with a fully outlaid kind of electrical grid drop down, right? You can get rocking and rolling. You just got to pull into it. You want to talk a little bit about the technology and how you came to that outcome?
No, great, and you know, I appreciate the other comments from the other two panel members. You know, nobody has a crystal ball what tomorrow brings, but what we do know right now is that the cost of transporting children, if you look at the cost of the vehicle and the cost of the infrastructure, it's dramatically higher, right? And so then we have to look at ourselves in the mirror, and if our goal is always diesel parity, how do we drive that narrative? And how do we get there to deliver to our school districts same cost, whether it's an internal combustion engine or it is an electric vehicle, i.e. diesel parity? It's through innovation. And one of the innovations, you know, as in our situation, to much like what you've had happen in Boston, you know, you can't put a backhoe bucket in the ground when it's 40 below zero. And if you look at the inclement weather, a lot of the facilities where these vehicles set are leased, right? So then you have to ask the question, do I want to move on to a lease site that I'm going to leave a lot of capital infrastructure if and when I ever have to leave? One, if I ever, to Craig's point, need to re-geometrically configure the location. Three, I want to be able to, the way I look at this infrastructure and, you know, in this most simplistic way, I go to Walmart, I buy a hairdryer, I take it home, I plug it in, I turn it on, and I dry my hair. The charging infrastructure is an appliance, right? And where we see these insane times of 6 months, 9 months, a year to install infrastructure, we've got to be more nimble than that. And our solution, and again, innovation from necessity, as we factory build that down an ISO 9001 certified quality line, that I get the same thing no matter where it's going, and the fact that we can load it all on a flatbed and ship it to a location, and now I can throw the go switch in hours or days and not months or years.
What's inside that box? What is inside there? Give people a sense of that. You're very close to it, so you know, but I don't think the audience knows.
There's a litany of infrastructure in there, from the gear, communications, fire detection. It has to be service rated, rated for main power coming in. So I look at it as a hub and spoke. So the hub of the wheel is the box, okay? The strings, where you pull the vehicles up to charge, are the spokes. The spokes go back to the hub, right? And it's all intertwined and above grade. Now, not saying that's the solution for everyone everywhere, but back to how do we together, as we take this journey to Destination Zero, through innovation, how do we steepen the curve and continue the electrified front to keep the ball going as fastly and as quickly and as cost-effectively as we can. What we've tried to do is there's been so much innovation across the entire industry. And Craig and I were talking about this. It's quite humbling, at least for me, to have a seat at the table to see this, I think, history being made as we have these conversations in not only how we move children, but as well as, in my own personal opinion, as we heard a little bit earlier, I think we're going to shape the nation in how energy is delivered to customers, right? I mean, I can tell you right now, you know, we as a corporation, we control somewhere just south of 400 megawatts. That's a lot of power. And if you then think about the curves at what we are all going to electrify and how much power we as an industry are going to control and how we might help our fellow citizens in power distribution, power storage, we are literally on the cusp of making history every day, and it's exciting to me. I mean, every day I get up, I'm ready to turn and burn. It's exciting.
Craig, you want to comment?
Yeah, and one of the things that we found, you know, the traditional model right now is using a make-ready program. Say with a utility, they're going to give you a certain amount of cash, and then you're going to also be responsible for X amount of kilowatt hours over the course of, say, 10 years to help them capitalize the thing. And that could be, you know, 3 or 4 megawatts of hours over 10 years. With the component model that we're talking about, again, the possibility exists that that is on our side of the meter, and therefore it will qualify for federal funding or for state funding, whereas the traditional make-ready program, the switchgear and transformer, is on the utility side of the meter, and EPA, for one, has been very adamant that that will not be funded. So that's what I think excites me more than it really excites me, that, my goodness, not just, I can pursue funds not just through clean school bus rebate or heavy-duty rebate, but also through entirely different model of just the IRA infrastructure rebate program that has nothing to do with CSB. So there's a couple of different streams that could be available, and I've heard varying ideas of whether or not it's available or not. I'm hoping, you know, that we're going to get that final decision from the federal government. But if in fact it's true that it's on our side of the meter because we're going to own it, I think that opens up a whole new world for us.
Interesting. So we get Craig's slides teed up because I want to make sure and share some of the real world data he's got, which the audience should see. But before those get pulled up, you know, let's talk a little bit. I'm going to throw it back to Alex too, because I know you guys were comparing notes too in terms of fleet performance, KPIs that you have, because you have dollars that you need to justify in terms of the cost per kilowatt hour. You need to look at all the situations that you're in. So what does that look like for you in terms of vehicle performance data, in terms of optimizing the electric fleet versus diesel, kind of like what you were talking about, in terms of trying to get to some cost parity where it financially makes sense? Because I think a lot of people in the audience, you know, it really comes down to how is it sustainable without a federal subsidy? Because the money has a certain time horizon, and as more time goes by, you know, I don't know if we're going to see this kind of federal money ever again for our industry. I'm hopeful that, yeah, maybe we will, but we have to plan for the worst and hope for the best, I think, in this situation. So how do you envision that in terms of performance indicators for a student running at such a high volume of miles? Because you have the most miles driven at this point that I'm aware of. So,
yeah, Tony, we're somewhere around, we'll just say 4 million-ish miles on EV operation. Again, you've got a lot packed in what you just said. Let's start with performance metrics, okay? It's not all about the vehicle. I call it the triangle of success. And the triangle of success is 3 things. The vehicle is one of them. The other pillar is the charger. And then the third pillar is the CMS. and the CMS is the charge management system. So if you look at a set of metrics on how you manage your business, whether or not it's kilowatt per mile, it is what's your actual bill that you're paying from the utility, because are you utilizing the charge management and charging in lowest cost tariffs as number two. So there's a whole litany of things that are in there. And then if you look at the CMS system and the charge management system and its interface to the vehicle and its associated, there's a whole set of metrics there as well. There's a whole litany of what are the key performance indicators, because all three of them have to work. If you think about where we are in relation to internal combustion today, hey, look, as long as you got a full tank and the bus is sitting there and the 12-volt battery's up, the probability that it's going to go and haul the children's high. Well, not so much today, because if my charger went down through the night, then guess what? We're not hauling the children the next day. Or if my CMS system bricked and it wouldn't allow the charger to fire up, or there was another glitch and you don't have the capability for being islanded, unfortunately, you're not going to probably run. So we're in a different space today than what we were and what we are with ICE. So I hope that answers a little bit of your first question around performance metrics. It's not just the bus, right? It takes three of them to make the wheel go around. Secondarily back to my earlier comments, we don't have a crystal ball in what's going to happen to funding opportunities out there. And I will say, and I'm glad you brought this up, because back to through innovation, working between operations, the districts, and the manufacturers on how do we get this down to diesel parity, I think is going to be a tough lift for us, to be honest with you. But we have to keep pushing forward on that front to make that happen, because we don't know what tomorrow is indeed going to bring.
Sure, thanks for that. So if we could pull up Craig's slides and then have you talk a little more, Craig, about what you're seeing specifically in terms of your fleet performance. Now, you're operating renewable diesel, which is not available to everyone, renewable propane, which, again, it's limited in certain places. Diesel, that's traditional. A lot of people are running it. You wake up in the morning, like Alex said, buses run. Now you've got all these other types of fuels that you've tested and now enter electric. And it brings a whole other litany of challenges, right? So let's talk a little more about the performance of what you see. So less expensive to operate. So let's talk about that a little.
Correct. So the first thing, we put the QR code up there. That is a access to our public website. Every month, I update the figures, the KPIs that we've developed and come up with, and we measure a variety of things, and we're still moving on that. Part of the reason for the project that we got into this was that we're committed to share the results, and we wanted to implement multiple platforms. We're using 5 of the 6 OEMs out there, so we're getting a good flavor, or we will be getting a good flavor across the things. We also wanted to work with, collaborate with scientists. We've already spoken with the NREL folks up in Denver in the propane office, the WRI, and the OEMs directly. And so some of the things that we're looking at, again, is kilowatt hours per mile. Because we're in a mild climate, we're at 1.87. So we use 1.87 kilowatts per mile. And Alex can speak to this. Depending on a more severe climate, you could be up to 2.5 or 2.2. I've always under the impression 2 is a good place to be, so we're pretty happy with that. But I also measure miles per kilowatt hour, if nothing else, just as how far can we go on 1 kilowatt? And the good news is right now it's only about a half a mile when you do the math out, and that doesn't sound like much, but it started a lot worse than that. So the numbers are going in the correct way. The biggest thing for us, again, is looking at cost, looking at the total cost, not just the fuel and electricity, but also repair costs and work orders and things like that. And again, looking at some of the things we found so far, for example, our cost per mile for a diesel bus is $1.06 per mile. Again, that's a non-wage mile. That's just an operational cost. And Propane's is less, 72%. We run about 65 propane buses. But when you look at electricity, it's half of diesel. 56 cents per mile is what it costs between the fuel and the operation costs because of the, just the shortage of what we're having to do on an annual or on a safety check and things like that. And then the average cost for the bus per month. This is what it costs, the total cost, by the bus. $850 a month for a diesel bus, $680 for a propane bus, not bad. $363 it's costing us now over the course of the last 12 months, July through June of 23, 24. So we're at, less than half, 2.5% less, cost to operate that diesel bus. I calculated our total savings. We saved about 111,000 gallons of diesel just by using electricity. That came out to $102,000 savings this past fiscal year of what electric saved us. And that's taken into account. It cost us $9,200 for that electricity versus that $111,000 it would have cost for diesel. So $102,000. That's and again, that's only, we scaled up to 25 buses by March. We started out with 5 or 6 initially in the year. So I'm really looking forward to this year where we're starting off at 25 or 30 and going from there. We'll get some really solid data points. So the cost numbers aren't lying. It's definitely cheaper. Again, there's some long-term sunk costs, as Alex talked about, that could mitigate that some point. But I still firmly believe that it's cheaper. And just, the non-measurable benefits of just the quietness of my special ed buses. The vast majority of my 25 buses, 20 of them are on special ed routes. And just the quietness and all those things that go along good with transporting special needs kids and kids that are on the spectrum that react to sounds and things like that. They're almost immeasurable. I'm hoping to figure out a way to measure it. Maybe a reduction in the number of instances we have. I'm not quite sure, but I'm confident that we will continue to see improvements in student behavior and things like that.
Yeah, real halo effect. We definitely hear that. Ken, you want to talk about kind of what you see in terms of, is it less expensive to operate? Is it not? And really, we know the cost for the asset is more. So, you have to look at kind of that cost-benefit analysis. At this point with the funding, yeah, it works good. So how does that financial element look in Boston?
Yeah, I think I share similar concerns, I think, to
Sure.
what were mentioned by my fellow panelists here. I think, yeah, operations costs were still, I would say the jury's still a little bit out. Again, we've been operating in 18 months, but I wouldn't, we're seeing costs come down, but there are certain areas that I want to work at further. And I guess I'll say, especially on the vehicle to grid or vehicle V2X is what I'm really interested in, and just ways to bring the cost down, using the novel parts of this technology, and hoping that's a solution. But yeah, in the current term, we are seeing about similar costs for electricity versus the diesel.
Got it. Yeah, our time is absolutely flying by here. So, Alex, I'll throw it to you because obviously 4 million miles. You got a view on that.
Yeah. I'll say that I agree that on the facade, in relation to ICE, cost per mile is cheaper, right? If you think of a diesel bus getting 7.5 miles to the gallon, and I agree with Craig, 2 kilowatts per mile, average cost per kilowatt in the nation's 8 cents a kilowatt, HR, is pretty cheap. However, here's where you've got to make sure you look at the total holistic picture. For those of you that are going V to G, right, and you're dramatically upping the duty cycle on those batteries, not only the amount of energy that's being moved in the cycles, right, and for those of us who may have harsher duty cycles on the batteries, be it range constraints or combo traction motor, V to G or V to X. I know we're talking a lot about V to G, but there's a whole other litany of things that we'll put in the V to X category. The point in case there is it ups the duty cycle on the battery, and if you really do an analysis of each manufacturer's warranties and what those look like based on chemistry, you start to get a little bit of, they're not all in the same place. And so let's just say you've upped that duty cycle on that battery, and in year 7, you've got to swing all the batteries. Well, buckle up. Because unfortunately, that's going to be a fairly large ticket item to replace. That then goes into the overall total. Because let's not just look at cost per mile, let's look at total cost of ownership, right? So my only point there, then if you look at, we're maintaining a vehicle now that everybody's on a race to 800 volt, and it's my opinion in the not so distant future, we're gonna see nominal voltages head towards 1,000 volts, right? So then when we start talking about, well, how do we train our technicians? What's the equipment, insulated, dielectric, special tooling, arc flash suits, conforming to NFP 70E. There's a whole litany of things that go into that total cost of ownership. So I would caution everybody, you need to look at the holistic picture so that for your individualistic organization, you understand short-term, cost per mile, long-term, what's that thing gonna cost you over the long haul?
Yeah, and we talked a little bit, I know we're running out of time, but one big question that always comes up is residual value, right? The buses haven't been on the road that long. I know my diesel bus, I'm gonna get X for it based on the mileage. Now, obviously, if you're in a cold weather climate like Kian is, the buses, you see rust and you see degradation. And so a lot of people say, okay, the batteries are the true value within these vehicles in terms of second life and things like that to really, so how do you guys really look at that? And that's kind of our final question of the panel. So, we've got to make it a quick one, but, Kian, you want to talk, how's Boston viewing the residual value of vehicles? I know you were being pushed because you're going all electric, so now you got to deal with all the ramifications of that.
Absolutely, yeah. I think one area, so yes, fully agree also on the warranties. I will push certain manufacturers in the room to up their warranty, please. I want to do vehicle to grid. I'm gonna call you out. I'm also gonna encourage those manufacturers to vehicle to X communication standards, -20, let's do it. Let's get there.
I agree with you, by the way.
I think, sorry, now I'm also just, the other last major thing I just wanted to say is talk to peers directly. I think other schools, super good valuable point there, but.
Okay, wonderful.
Well, I just wanted to say one quick thing is, one of the things that I did is I went out and did a 20-year replacement plan. Now, a lot can happen in 20 years. I'm more focused on the 10 years, but one of the key things I found, especially when you're getting $390,000 per bus and the bus only costs $375, you've got that bus free, but you have to replace it in 10, 12 years. And one of the things is look at it and see what's your replacement plan gonna be. One of the things I found is you can't do it the traditional way of this bus expires or this bus retires and I'm just gonna buy this replacement. You're gonna need, especially when you buy them in bulk, I found, spreading that over the course of 3 or 4 years. And some of it, you're gonna start buying them a little bit before their life ends, and some are gonna be a little after their lifespan. So make sure you spend the time to do that. If nothing else, that you can explain to your bosses, here's the plan. There's not gonna be a cliff in 12 years or 15 years that we're gonna fall off of, that we have a plan to get there, assuming that the federal money and state money isn't there to help us, so.
Alex, last thought?
I'll just say back to the battery question. I've got a pocket full of business cards. Anybody, that wants to get rid of their batteries, please come see me and I'll give you one of my business cards. We'd love to have as many as we can. Now, that being aside, it's all about the battery. Let there be no mistake. It's all about the battery. And actually, Tony, it's not first life traction motor, it's second life and third life, right? So let's talk about it from cradle to grave. So we know, and the jury's still out based on chemistry, duty cycle, a lot of factors in that equation on what that curve of degradation looks like, right? So depending on, all those variables, when you're gonna have to swing it, when you get to the 80% SOC, that it'll no longer do the range that we need it to do, and what do you do with it in the second life, right? So we've had a lot of conversation tonight about V to G, V to X. There's a whole litany of uses for the second life batteries, right? That's one additional step in their evolution on how they get redeployed, and they are extremely key contributors, I'll say, to our overall national strategy for success on power, and I'll leave it at that. Then you've got the third life in its normal evolution, which is the recycling, right? So a lot of aluminum, a lot of plastics, black matter, ooh, that's worth a lot right there, right? So how do you ultimately recycle that battery in its third and final life? So for those of you who don't have a cradle-to-grave strategy on such a very key important asset, I would highly recommend you think about that, and what are you going to do with that, and how are you going to handle that? And like I said, we'll take the batteries off your hands. Just come get one of my cards.
Thank you, thank you. Yeah, so we are at time, and I want to thank the panel for sharing their thoughts and their journey to kind of scale and really look deep at really the costs. And, it's not a rosy picture always, right? There's a lot of complexity to this, and I think as school districts and operators look at making an investment, work and lean on your peers. The panel up here is more than happy to work with you and talk with you more. Craig has all that great data on his website, which we'll share too on the STN website more. So we want you to be successful in your journey, whatever fuel type you choose. So we talked a lot today. Battery chemistry is evolving. We're seeing LFP become industry standard. We're seeing the potential of drivetrain axles in the future. So the OEMs are going to evolve the technology as well. So the technology you see today could be very different 24 to 36 months from now. It's a really fast-moving process. And again, the value, as Alex said, we see it in the batteries. So we'll look more towards this throughout the day at the Green Bus Summit. Right here on this stage, we have Justina Morrison, Vice President, General Manager of IC Bus, doing a keynote for us. So we'll be back at 9:30 for that. So take a quick bio break, grab some coffee. Again, courtesy of Roush Clean Tech. We thank them, and we'll see you back here in about 10 minutes. Thanks, guys.